Okay, we're going to look at something called gradient today. Now, another word for gradient is slope. The gradient of a line is a measure of how steep the line is. Now, as you move along the line from left to right, if the line is sloping up from left to right, we say it's got a positive gradient. So this line here slopes up from left to right, so it's got a positive gradient. A line that slopes down from left to right, we say has a negative gradient. A line which is horizontal obviously doesn't slope up or slope down. We say that's got a zero gradient. Now a vertical line that's not sloping up or down to the left or the right, we say that's got an infinite gradient or an undefined gradient, right? Completely vertical. Okay, so let's have a look at the first few questions here. Now you can see here that the line is sloping down from left to right. So we've got to say whether the gradient is positive p, negative n, or infinite I or 0. Now sloping down from left to right, so that's a negative gradient. Okay, so n for negative. This line is sloping up from left to right, so we say it's got a positive gradient. Okay, p for positive. This line here, again sloping up from left to right, positive gradient. Okay, this line here, sloping up from left to right, positive gradient. Now this line is vertical, so we say that it's got an infinite or undefined gradient. Right, and the next line, sloping down from left to right, we say that's got a negative gradient. Okay, negative. And the last one, this is a line which is perfectly horizontal, so we say it's got a zero gradient. Okay, zero. All right, now let's look at how we can calculate a value for the gradient. Right, now here's our definition. The gradient of a straight line is defined as the ratio of the vertical rise to the horizontal run between any 2 points of the line. The symbol for gradient is m. Now, I know you're thinking the symbol should be g, but g is reserved for gravity. Okay, and just one other thing, another word for gradient which will come up is slope. Right, they mean the same thing. So gradient is the vertical rise over the horizontal run. It means you pick any 2 points on the line and you work out the horizontal run. So to get from one point to the other, you've got to travel along a right angle. So you work out the horizontal and vertical travel components there. Okay. Typically we do the rise part first. I would be starting at the top point, going down and then left. Okay, but we could also go the other way. In other words, I could start from here and do the rise component here first, then go across. Okay, so that's also the rise and that's also the run. All right, so once we work out the rise divided by the run, that gives you a value, and we call that the slope value or the gradient value of the line. Okay, so let's have a look at our first question here. All right, so we've got to calculate the gradient of the line below. Now, the way we do that is we look at 2 points we can be certain of the coordinates. So I'm going to choose this point definitely is on one of the grid corners. So I can definitely know that's the coordinates -2, 4. And I'm going to choose this one as well. I definitely know it goes through -2. But you could have chosen any other 2 points on the line, right? Because the steepness of the line is the same between any 2 points. Okay, so what we're going to do is work out the rise over the run. So I'd like to do the rise component first. So I'm going to start here. I'm going to go up. and then I'm going to go left. Oh, didn't keep that too straight. Try that again. And then I'm going to go left. There's my right angle, so you've got to form a right angle triangle. I started at -2 and I went up to 4. So the rise is 6 units. So I went up. Then I went left. Now you've got to be careful here. We know that left, we're going to allocate left as the negative direction. So I went left. How far did I go left? So I went from here to -2. So we're going to say that the run component, which is a horizontal component, is -2. All right, that means my slope or gradient, m, so m is the symbol for gradient, which is rise over run. That is 6 for the rise divided by -2 for the run. That's -3. Now we should get a negative value because we can identify this as a negative sloping line. So just as a rule of thumb, if you're going up, that is a positive direction. If you're going down, that is a negative direction. If you're going right, that's positive. And if you're moving left, that's negative, right? So you'll need that orientation to determine if your rise or run is negative, depending on which direction you start from. Okay, moving right along. Okay, so these are our steps. Choose any 2 points on the line, form a right angle triangle, determine the values of the rise and the run by traveling from one point to the other. Traveling right or up is positive, traveling left or down is negative, and then you substitute into the formula. So let's try that for this one. I've got to choose any 2 points on the line. Now, I want to be sure of the coordinates so I can count the squares. So I always choose a point on the corner of the grid. There's one, and here's another one. Okay, you could have chosen another 2. All right, so I like to do the rise part first. I like to go up first. Up, and then I go across to form a right angle triangle. There we go. Okay, so I started here and I went up. So I went up 2 squares, so the rise is 2. And then I went left, 1, 2, from -3 to -6, 3 squares. So the run is -3. So up, positive direction, and then I moved left, negative direction. So the run is -3. So the slope of that line, write the formula down, rise over run. Rise is 2, and the run is -3. So your answer is, you could put that negative sign anywhere you want, it's -2/3. Okay, and again, you'd have been expecting to get a negative value because that line is sloping down from left to right, so it's a negative slope. Okay, let's move on to the next one. This time, they don't give you a line or an interval, you've got to plot it. So -4, 2 is the first point I'm going to plot, which is here. And then 4, 6 is the other one here. So if they don't give you the diagram, you have to draw it yourself. Now I'm going to join those 2 points. Right, so I'm going to find the slope of that line. And let's do the rise and the run. So again, I like to do the rise part first. So I'm going to go up along the vertical line, right? And then I've got to go horizontal to travel to the other point. Okay, there's my right angle triangle. This is up and this is right, both positive directions. So the rise, if you count it, I'm going from the pink point, 1, 2, 3, 4, I've risen by 4 units. And the run, well, starting from that corner there, I've gone from -4 to +4. The run is going to be +8. So the slope of the line, rise over run, is equal to 4 over 8 which simplifies to a half. It's a positive value, which matches what we observed. This is a line or an interval which slopes up from left to right, so we would expect a positive value. Okay, let's move on. You can maybe pause the video and try this one yourself. Right, so -2, 4. I'm going to plot that there, and then 2, -5. So we've got to go down a bit for that one. So 2, -5. All right, then I've got to join the line here. Join the 2 points. There we go. All right, so I'm going to form a right angle triangle now. So let's do that. Well, as I said, I like to do the rise part first, which is the up part. So I'm going to start from down here. So just dot in your vertical line. There we go. Now I've got to go horizontal. So I've formed my right angle triangle. Now I started down here and I went up. Then I went left from that corner to get to the other point. So the rise component, well, I started at -5, ended up at 4. So the rise component must be +9. The run component, well, I started here at 2 on the x-axis and I went across to -2. So the run, because I'm going left, it must be -4. So write my formula down. Slope equals rise over run, which equals 9 on -4. Now again, we'd expect a negative value for the slope because the line is sloping down from left to right. Okay, and that is it for today.